We've got a good, decent show for you today. Changed my mind mid-flight. That's because I'm opening up, but we do have a good second half of the show. We've got a panel full of folks that really know what they're talking about. Some of them are up here within heckling range, so yeah, you'll get your turn. Very pleased to be here. I want to ask, for how many of you is the topic of service mesh rather new? You're being introduced to it, sort of conceptually. Very good. Well, not only precisely as I had guessed it, but most of you are in the right place then. So this is good. Two things to take away from this. I make corny jokes and like to be social, so please be social. I'm here to share what I know on this subject and a couple of others. The only other thing maybe to take away from this is the link to the slides is the URL there in yellow. I don't think that the slides are up just yet for this one, but they will be. And so look at that, I'm already sharing. So speaking of sharing, and speaking of folks who know what they're talking about, Mr. Zach Butcher is up here. He's a co-author of mine on a book that's, well, past deadline. And that's how it goes. But it is under early release, so if you're an O'Reilly Safari subscriber, you can go see the uncut version now. And but you can subscribe at that URL to be notified or to find out more about what the book is. And actually at that URL, layer5.io, you'll find it's something of a service mesh community. And so there's a fair bit of info there. We might talk about that a little bit later. I don't know that I've seen a service mesh talk that didn't introduce the topic through the lens of microservices. That makes a lot of sense. It's the environment in which you probably have the biggest return on investment for a service mesh. You'll find that if you're running a lot of microservices, you deploy a service mesh, sometimes you might find that the blinders come off. And you actually comprehend what's going on. You've got a lot more visibility. You probably find you have a lot more control. And maybe things become a bit more secure. And by the way, whether we begin to get interactive right now or a little bit later when we have panelists, there will be questions and there will be solicitations for questions. So we're going to start with a couple. Lofted softly your way. Here's your second one. And that is, do service meshes, is their place constrained to container and microservice land? Do you consider that they might have value outside of that for the other 70% of our world's workloads in VMs or on bare metal or mainframes? They do. They do. You may not gain as many benefits as you would if you were running lots and lots of ephemeral things, and we're having to track those and secure them in a different way. That's actually one of the advantages that we're going to talk about with the service mesh, that these things are service mesh, and there's a variety of them. We're going to look at some of those today, are applicable not only in containerized environments, but also outside of containerized environments. As a matter of fact, it's a way in which some might, or many will come to a service mesh and find value in it without having containerized anything, which is, now that I'm sort of articulating it in this way, I'm beginning to feel uncomfortable. It's almost heresy at DockerCon, specifically since I'm a Docker captain. And so if we could edit out that part later, I'd like to continue to be a Docker captain. That wasn't my point. My point was that you'll find lots of value in both worlds. So this is a burgeoning and really in my mind sort of a third step that some take within their cloud native journey. I'm going to do some tongue-in-cheek things here today, and that's one of them. This isn't necessarily your third step. Maybe your first step is containerization. Maybe if you're doing something very meaningful with a lot of containers, that second step is container orchestration. And then maybe when you can't figure out what's going on and you need some control, you bring in this third phase of a service mesh. That isn't the only path to cloud native. There's lots of those different ways. Point here that is to be made is that this is there's a burgeoning ecosystem of not only service meshes themselves, but some other things that look pretty well, that overlap with some of the value that you would derive from a service mesh. It's been said that client libraries, so maybe another question, the term client libraries, does that resonate with some folks? Those that are doing microservices, you probably run across microservice frameworks or client-side libraries that you would incorporate into your application to help you with some distributed systems concerns, mostly around the network being an issue. And so some of those are GoKit, Hystrix. There's a number of others. They're here on this page. And so I think that, if you're like me, it's really helpful when I've learned one thing and I've got kind of that mental model for how that thing works. If somebody could compare that to something, compare the new thing that I'm trying to learn to the thing that I already understand, that really helps my small-minded. And one of those that I feel like I really, understand pretty well is a container orchestrator. At a high level, I've already mentioned kind of at least in today's service meshes, the sort of top 3 categories of value that you would derive from them. I had said, I said take the blinders off, and by that I meant gain some visibility, gain a lot of observability, gather a lot of new or additional and some new telemetry that you are maybe not likely to be gathering today from your container orchestration system. That's one. Another one is some fine-grained control, specifically at the application layer, at layer 7. The third one here being security, and fine-grained security that maybe you don't have in your environment today. And we'll ask this question of some of our panelists later, but in my mind, there are other categories of capabilities, things that you might come to expect from your network, from your service mesh network. Today, those are the 3. And if you're saying to yourself, if you're asking this question, well, hey, of those things, but I'm running Swarm, or I'm running Nomad, or Baseless Marathon, I'm running Kubernetes. I've got some visibility, I've got some metrics, I've got telemetry, I've got some control. There's network policies, there's other types of control to be put in there. Well, yeah, this is entirely accurate, hence the confusion. I would put it as that containers or container orchestrators specifically, and here's another bit of tongue-in-cheek for you, but have had to focus necessarily on infrastructure concerns, layer 4 sort of on down centric. That doesn't technically mean that Kubernetes and other container orchestrators aren't doing things at layer 7 and taking care of some of those concerns. But that those projects have had to focus on nodes, clusters, forming them, providing admission to them, managing, scheduling very efficiently. Yes, there are some health checks that you would consider, like, hey, if it's container orchestrator schedules a container, they would do a health check. And that health check is possible to do at layer 7. It's also kind of oftentimes by default, just at a container level, not necessarily for the number of processes that you're running inside, and whether or not, it'll check if they're up, but maybe not whether or not they're actually responding in the right way. And so, by way of just a quick example there, my point being is those lower layers have been fairly well considered for, but at an application level, they maybe haven't been all the way considered for. So I'm going to make a couple of statements today that you're welcome to beat me up on Twitter about, or or our esteemed panelists can take a crack at later. One of those is that, my perspective is that, container orchestrator, or that you can't call something a container orchestrator unless it has these three capabilities. Cluster management, which I just talked about, establishing nodes, forming clusters, taking care of them. Service discovery and scheduling. And you can see that container orchestrators do these other things very well and provide a little bit for applications. And as the years have gone by, more and more application level concerns have been considered for. But there's a lot more left. Hence, still a place for the service mesh to play. And service meshes generally rely on, operate at a higher level. I would argue sort of layer 5. And that you'd, and as we're gonna show today, you'd often find that they're deployed on top of other infrastructure. So a container orchestrator being one. So intended to be complementary to a container orchestrator. You might also be saying to yourself, well, hey, some of the things that I didn't say specifically yet, but I said you'd get better fine-grained traffic control, things like rate limiting, circuit breaking, retries and timeouts, those kinds of things. That some of that starts to sound a lot like an API gateway, and that's true. There's some overlap there. Some of the nuances, I think it's been articulated that some of the more macro level nuance there, in terms of a difference between an API gateway and a service mesh, is that API gateways tend to be deployed outside the cluster, dealing mostly with north-south traffic, if you will. Service meshes tend to deal with east-west traffic. And I recognize that directionality may not make a lot of sense right now unless you're a network engineer, and then it maybe does, or unless you're another type of engineer and but that's the macro level. We're going to get into some other details about describing that. There's also another nuance to throw in here, and there are those offerings and projects that label themselves as an API gateway. There are others that tack on an additional, I was going to say an additional marketing nuance, but I don't believe it's just a marketing nuance. There are those of a class of kind of microservices API gateways, and these are the ones that are fairly developer friendly. Kind of API friendly, and also have native integrations with modern infrastructure, like container orchestrators. Okay, well, if those other systems are providing those things, like what else is it that we need? And we need, each of these things, the things that I've just mentioned, I didn't say resiliency, but you need, clearly you need a service mesh, which is why you're here. But to describe a service mesh a little bit better, here's the verbatim, I think this is from Istio's site, which like obviously this very well defines what a service mesh is, and then if you're like me, that means nothing to you. And so some have said a microservices platform, and maybe that's true, but it's also been said that service meshes are something of a services first network, a network that is there to provide you the things that you would need to handle within a distributed systems environment. To understand the fact that the network is now part and parcel to potentially every single interaction, every single piece of functionality that's happening within your distributed app system, within your distributed application. Service meshes aren't going to give you everything that you need. I think if you've read if you've been introduced briefly, if you've read a 30-second description of the service mesh, you've heard things like, and these promises are true. There are some asterisks in some cases, but that you'll gain a lot of these benefits, not necessarily with any code change to your application, and in many cases, not any code change to your manifest, to your spec files either. It's a pretty sweet deal. There's a little bit of magic sprinkles that go in there. We're going to try to illuminate some of those. Point is, service meshes don't get you all the way either. Part of what I was going to say is that of some of the visibility and new telemetry that you'll gain out of a service mesh, at least as they are today, there's a fair bit of that is black box to your application that's running inside your container. The one notable exception there is the facilitation of distributed tracing that you'll find in most service meshes. And then that's sort of full-blown APM. Well, not full-blown. That's quite a lot of visibility, and certainly falls into the classification of application performance management, APM. Okay. I mentioned before that we talked about client libraries. Client libraries are really more infrastructure-centric concerns. The timeouts, the retries, the when to circuit break, the other concerns that get embedded into your application, and they become bothersome because you've got to version those, and versioning those means doing another deployment of your application. Sometimes you're using multiple languages within your application, and so you've got different client libraries. And so you've got to version those. And actually some of those concerns around retrying on the network or backing off and doing these algorithms intelligently and correctly, it's not easy, it's hard. And moreover, it's probably not what you're trying to write and what the value that you're trying to deliver. And so to the extent that many man hours, engineer hours have gone into the build out of service meshes, you can begin to rely on them for these infrastructure concerns and unbloat your code, pull those client-side libraries out of your code, rely on the service mesh for those things. So you don't dedupe work. You don't have inconsistency if you're using different libraries. You'll have a consistent, uniform control and visibility out of a single mesh. So here's a couple of examples of observability. So observability, there's lots that the service mesh sees when you, and we're going to show some visual examples here of all traffic, all service requests that go to your applications flowing through the mesh, and the mesh understanding that very well and being able to crack open the TCP headers and the HTTP headers and introspect the traffic. There's a lot of insight that can be gleaned from within there. There's a lot of new telemetry that can come out of that, a lot of new visibility that comes forth. This is probably the number one thing that hooks people on a service mesh, or maybe attracts them to a service mesh initially, is just to understand what is going on in my environment. That's not, I mean, certainly others are attracted for different reasons, some of them being these: fine-grained traffic control, layer 7 steering, so blue-green deploys, canary deploys, doing things in a declarative way, controlling the way your traffic is flowing in a declarative way. Maybe opening up the packet and looking to see if Bob is signed in, or if he's belongs to a certain account that is over their limit, or needs there of a certain account that's on the beta program, and just traffic gets redirected there. You're able to define that and tell your mesh to do those things, control your traffic and control that flow without code change. The resiliency here is pretty interesting, certainly an attractive component. And it's not just about providing resiliency by doing circuit breakers and these health checks and rate limiting and things. It's also about maybe instigating a bit of trouble and maybe creating a bit of chaos and seeing what happens. If you consider that these service meshes are powerful by way of their network capabilities, they're able to induce latency, drop a few packets, shut things down, see what happens. So can be a great facilitator of chaos. There's some security things that I did, and I'm skipping over and not, maybe I'll mention it briefly. I'd said that the third pillar today is probably security, and that is you'll hear about mutual TLS and peer-to-peer authentication and encryption between your microservices. So no longer necessarily having a soft GUI center inside of your cluster and a hardened outside, but rather hardened through and through. Once you begin to just take that for granted and that's how your infrastructure runs, imagine you'll run it maybe a little bit differently. So there's some things to change here. Not all service meshes are made the same, which is why we have panelists today from different, representing different projects and offerings. Some of them, we can characterize those, I think, for a long time. This slide here is highlighting one of the capabilities that Linkerd had touted and or touts, and actually point of clarification, since we're on record, William, is this are deadlines a Linkerd 2 thing as well? Okay. But and so you guys have clearly been taking those learnings from Linkerd 1, putting them into 2 at blazing fast speeds. And so I'm not going to describe this capability. Hopefully the slides actually make it somewhat obvious, in part because we've got 25 minutes left. One other thing, we're gonna get our hands into some demos and things that I want to highlight here. This is, well, I've certainly heard others say, actually, hey, Lee, it's not necessarily the security, the control, the observability, and other things yet to come. It's actually the notion that now what you're doing is like you're diffusing responsibility, you're giving a new tool set and a new level of control over these concerns, and empowering the devs and the ops to iterate a bit independently, to move a bit more quickly. If you were listening to any of the keynotes, I think the notion of speed was probably the underbelly to much of the context of why people do, why we're doing containers, why we do cloud native things, why people deliver SaaS, not much more so than they do shrink wrap things anymore. And it's for speed. And so point being is, to the extent that these teams have a new tool, they can move faster. Let me demonstrate this by maybe asking this question. So again, I think we're on like our 4th or 5th question this way. So I'm going to expect them back later. In your environments, for something like rate limiting an API, rate limiting an HTTP endpoint that you have, whether you've just got dev and just got ops or what have you, whose responsibility is it to define the rate limit and enforce the rate limit in your environment? Ops, very good. Ops, dev, who knows? And honestly, and that's actually, I'm sure that's an answer. I've spoken to lots and lots of folks about this particular topic, and the answers are every which way, and it's environment dependent, and my belief is in part because there isn't necessarily a standardized tooling or there hasn't been until service meshes have come along to declaratively provide control over this, source or version controlled declaration of how it is that you want these things to run, how it is that you want to limit your APIs and the rates by which they respond. So an important concept. This is one of those slides where I just like to take a moment and study the blueprint here. If you guys are, yep, okay, good. All right, somewhere in here I'm gonna make a statement. And it looks like it's at the bottom of the screen already. Let's have an argument on the panel later. Service meshes, you hear about 2 different planes. And if you've been in networking or studied it, these are probably familiar to you. As a matter of fact, if you've been using container orchestrators, a control plane and maybe a data plane that you've heard of, but you've certainly heard of a control plane. These things kind of make some intuitive sense, I think. The data plane here is where the service mesh handles all the traffic itself. This is intercepting all the traffic, watching all the traffic, controlling it, securing it. It's an important plane. It's got a heavy task to do. You will also see a control plane inside of service meshes. And this is where the operator, or maybe the developer, comes to define policy, comes to configure your mesh, how it is that you'd like for it to operate. Some have called service meshes, actually in general, configuration management for service proxies, which that's accurate. There's more than that. It's also, again, if your heritage is network engineering or not, you may be familiar with a management plane as well. We're going to give an example of a management plane here. Today, I don't think you hear those talked about a lot in context of a service mesh, but Maybe that'll change. All right, good. Here, a visual understanding of what I've been trying to describe with my hands and waving them frantically. If we take, so one of the service meshes that you might have heard about is Istio. Most of the service meshes have a sample app that comes with them to help you learn the mesh and demonstrate their capabilities. In Istio's case, this one's called Book Info, which is not to be confused with Book Catalog from Linkerd. But this is how traffic, so in this sample app, to familiarize with it very quickly, it is, boy, I'm having all the fun up here. We're gonna have some fun in a minute. Is this particular app does its job well. It demonstrates the power of a service mesh by saying, here's 4 services, they're all written in 4 different languages, whereas you'd normally have potentially 4 different client-side libraries. You can take those, the service mesh will dissolve those concerns, provide you with a lot of control. Your traffic flows like this. This is sort of taken in context of a Kubernetes environment. So you've got 4 services, they're running, it's just a simple book catalog. If you deploy it on the mesh, this might be what it looks like. There's a few different deployment models for how you do deploy service meshes. This one has certainly gained in popularity, and that is more or less by sidecarring service proxy. And again, in Istio's case, the default kind of out of the default batteries included are a service proxy called Envoy. So let's look at Istio's architecture in specific. Here's Istio's control plane. The blue dashed constructs, these 2 gateways are well, I think many might actually put the ingress gateway in a solid line and sort of say, hey, that's probably required. And that's probably a bit more accurate. Let's not focus on that though. Let's go to the control plane and look at the notion that the control plane components are, and again, this is presented inside of a Kubernetes context, that these control plane components are deployed inside of a namespace. There's a few of them that have different responsibilities, and let's not, there's other talks that go through all those. This is again kind of your sort of generic model of how it is that traffic would flow through, how it is that telemetry would be gathered and stored, how it is that policy might be checked on and enforced. People might, requests might be rejected. It's kind of nice. Linkerd. Some similar, some components that perform some similar functions. Linkerd is that set of maintainers has been at this service mesh stuff for a while, and moves quickly, and so that control plane, as it's described there, might be missing one newer component, and so, but is by and large accurate. So you're seeing a lot of similarities. Like I said, you'll find some differences as well. Okay. There's a lot of ways to deploy a service mesh. You guys have been listening to me talk for quite some time. Thank you. We're not going to go through those. Rather, what I would say is there's a yet to be stale, free short book on the subject that I would recommend that you read. It's not that long. It does go through a number of different deployment models, which I think are both help you understand why things have arrived at kind of this sidecar model of service mesh deployments, but also will help maybe energize you or encourage you that it doesn't have to be an all or nothing thing, that you can start piecemeal, start moving. If you were watching, I think it was the day 2 keynotes, the announcement of Istio Ingress and one of Istio's control plane components, Pilot, being incorporated into Docker Enterprise. Well, that was clearly not all the components that I just showed, and so they're clearly starting small, iteratively, doing things piecemeal. It's the right start to me, for me. So I was here last year, did a workshop on using Istio, and then I went around and gave the workshop quite a few times. I pretty consistently heard 2 questions in giving that workshop. They both very naturally started out with, well, this service mesh thing is fantastic. Like this is awesome. That's kind of how the question started. I was like, yeah, yes, I know. And then they said, but you talked about a few different ones. So hey, what do you recommend that I start with? Which one? What's the so wink? Which one's the one? And so I said, I think the microphone went out there. So well, you have to catch me after. No. So I did give an answer. Moreover, I felt like the answer needed backed up a bit. I felt like people needed a playground to go in and try these service meshes out relatively quickly. The second question that they asked, and it really kind of true of I think any engineer in the room, they'd say, well, that's fantastic, but wait a second. This doesn't come for free. You're talking about opening up like network packets and traversing them and introspecting them. How much is this going to cost me? I'm just going to be sitting here burning CPU. You're talking about deploying how many sidecars? How much memory is that going to take up in my, is this worth it? How much? What's the return on investment here? And so unlike the days of the container orchestrator where when people were trying to figure out which one to go and deploy and what the differences were, in those environments, people would characterize them in different ways. One of those ways was on scale and sort of resiliency, high availability. That was measured most prominently by a container orchestrator's scheduler, how quickly it could schedule containers across how many nodes at a given time. Here in service mesh land, as we go to face some of those same choices and go to understand different meshes and their value, one of those things is around, or one of those ways of comparing them is through performance. And so we set out about 4 months ago now to grab a hold of some interested folks to create a new open source project to help answer these questions. And it was to, one, provide a playground so that people could very easily deploy service mesh and play with it, understand its functionality. And then 2, facilitate some performance testing. Both performance testing of the sample apps that each of those meshes come with, but also performance testing of their applications, because they can take this open source tool, deploy it in their environments, point it at their sample applications, test their sample app, test their application. They can put it on the mesh, test the performance there again. And so, because naming open source projects is hard, we arrived here. Yes. Also because there's so many corny things you can say with mesh. And so this is a very simple project. Here's what it looks like. Most commonly, we expect that people will download the tool onto their local Docker environment. In my case, Docker desktop. And load up different adapters for different service meshes that they want to interact with. And then point the tool at a cluster, at a Kubernetes cluster. The tool will then facilitate deploying the mesh, deploying sample apps, and letting them perform some tests. Let's see if we can give a demo of, and so the tool is intended to ultimately, there's a number of people working on this. Ultimately, the tool is intended to help provide, do a public service around helping understand the different characteristics of service meshes. And not necessarily, certainly there'll be some comparison within there. Really doing an apples to apples comparison is pretty rough, but you can get kind of close. But maybe most importantly here is for people to understand for the given mesh that they are deploying, what are they giving up in terms of overhead? And so let's see if we can give a demo, and then show some results. There's a couple of a few different university students working on the project. I was going to say a couple PhDs and they've only been able to give it so much time, but we do have some results. I'm going to share some of those results today. So the tool itself, it can be found at that same site, layer5.io/meshery. In order to install the tool, these instructions are on the site, but it's just you go out and download its Meshery CTL. Once you've installed that, you can do a Meshery start. In my case, I'd already downloaded and started Meshery, so we're just going to do a Meshery update. There's the handful of container, the Meshery and the two adapters that the project has today for Istio and linkerd. Looks like those are running. Let me do a Meshery start. Okay, so we started it. It just by default opens up our browser. When you go into the tool, you may need to configure your environment. To point the tool at your Kubernetes system. In my case, I'm connected over VPN back to home office. I'm going to upload my local Kubernetes config. Submit that. It looks like it's interpreting it. Very good. I'm going to go and point the tool Meshery at the two adapters that we've got deployed, so our Istio adapter, our linkerd adapter. You can also optionally configure a pointer to Grafana. The tool will pull in, so if you've sort of invested time into those dashboards and things, the tool will pull in Grafana dashboards so that you can not only, well, yeah, I'll tell you why in a minute, but let's not do it in this demo. Let's leave something for you to go try on your own, but I'll tell you why. Okay, so hopefully we've got our environment configured. Hopefully we've got connectivity. You can use the tool to do something like install the latest version of Istio. And so the tool is off running, maybe to help with some of this. This, by the way, is a very simple environment. It's just a single node Ubuntu cluster. It's a VM. So we just told it to install Istio. Looks like it's often doing that. We can tell it to go ahead and install the sample application, the one that we were looking at before, book info. There's a vendor in the space, some of you may know, Aspen Mesh. It's been also started an open source project called Istio Vet. Anybody familiar with Docker Bench or Kube Bench? Some tools that define some best practices and let you run, and will run against your containerized environment and tell you, mostly if you're doing things wrong by way of security. Well, if you're familiar with it, Istio Vet is fairly similar. It's a tool that you can run that will execute a number of vetters. These vetters are just best practices for how you've got your, in this case, Istio environment configured. And so let's see if we can run it here. So it's running. We're getting back some messages, which is good. And so yeah, some of these messages are the Istio Vet just ran. It's telling me how many pods I've got that are not in the mesh. It'll also, a bit more interestingly, tell you when you've got something wrong and give you a little bit of info about maybe what you need to do to correct it. So that's good. Let's go ahead and do, and so that's great. You've got a playground. You can work with it, interface with the mesh. You can send it some YAML, update its config. There's, I'll leave other things to the imagination. You can run some performance tests. I had said that maybe we would take a look at that sample app. And that is not it. Okay, so a riveting sample app, book info. If we take that URL and point Meshery to it, we'll have to save this result. This will be a good one. There are, like I was saying, there's a list of service meshes. Some of which are supported today. We can go out and tell Meshery, this tool running on my MacBook, to generate some load. In this case, HTTP load over to this endpoint book info. Maybe, in this case for 30 seconds, because I can only think of one really good joke in 30 seconds while we wait. Okay, that's good. Okay, and And so right now what it's doing is generating load based on the parameters that I gave it. In this case, really just using a single thread, so a concurrency, a single concurrency generation of HTTP traffic over to this endpoint, do it for 30 seconds, do it at a query rate of once per second. And so it pulls back results, and it's using, if you're familiar with Ford.io, it's using Ford.io as a load generator inside the tool, using chart.js to display things back. It's going to show you a histogram of where most of the latency of the responses back. This tool is going to show you latency of your requests and throughput of your requests, and help you test that. I think I know the answer to this question, but who was here? Who was at Container World and saw me do, for the first time ever, a side-by-side performance test? And so there, okay, yes, one individual. I knew it. Well, guess what? You're lucky. This is you know what? I'm actually not going to do it again. I was going to say this is the second time ever that I would have run it. But let's pull that one up because I've demoed enough live things on stage. The tool itself will, one of the nice things, and so there's our result, that's great. It will persist your results, so you can come back later. So not dissimilar from an internet, I mean, in some respects from an internet bandwidth speed test that you might run at home to figure out if you're getting gypped by your service provider. What the tool intends to do is collect some of these performance tests anonymously, and again, do a kind of a public service back to share what the average latency is for different service meshes deployed, around the globe, or for whoever is deploying them. Container World was in Santa Clara 3 weeks ago, April 18th. We ran a test. The test was Linkerd, Istio, both running BookInfo, this sample app, and also the sample app not running on any mesh at all, just running on Kubernetes by itself. And the line breakage here is unfortunate. Let me switch the line breakage so that we can, I guess there's maybe a couple of things to show is that, you can select a couple of results and compare them in the same graph. So this is kind of nice. If you end up comparing kind of more than two, you will have to sit there and eyeball it for a little while. But that's possible. Let's go back to our April 18th results. We did we did a test with, oh man, is it breaking across the same? Okay, well, all right. So the test, I think I ran it at a concurrency of one thread for 30 seconds for one query per second, which is actually what I just did just now. And in that particular environment, again, there's lots and lots of variables within here, but of the two things that this tool is measuring right now is throughput and latency. And really, you're seeing just a nominal difference between these two meshes, both performing rather the same under these conditions. There's a sort of fat asterisk behind this because performance testing is just a bunch of variables. It's just a bunch of it depends on what you're testing when and what nodes it's running and all these things. This tool is intended to facilitate that. But I said we also ran a test that was of BookInfo at the time that was not on the mesh. And while it's unfortunate that they're not side by side so you can't see it, in fact, what was rather surprising, and even at the time I think to me, but not to our, not to Manish here, was that the slower responses were those from BookInfo that was not on the mesh. The slower responses were coming from BookInfo that was deployed on Kubernetes by itself, onto its own, not on the mesh. The responses coming back from the mesh, where you were getting security, visibility, and control, were in fact faster. There's probably a couple of different reasons for this. One being that right now, within your vanilla deployment of Kubernetes, you'll find that IP tables and net filter as a kernel capability are being used. And if you've heard talks about eBPF or IPVS, other Linux kernel capabilities, you'll have understood that not all Linux kernel capabilities are made the same. Point is, somewhat surprising, but actually in this case, being on the mesh was faster. Kind of neat. So enough with that. We're going to do more tests. Some of the tests have come back, and these are fresh as of this morning. Very seriously, all of these slides are, these last ones are fresh as of this morning. And so just even trying to grok them and internalize them myself as we got these back from UT Austin, from the excellent students that are working there, was this notion of this test being done on an 8-core system, a VM, a Ubuntu system, a single node deployment, has 8 cores. And so the insights that were being gleaned here was just to take, and again, there's a lot of kind of configuration of the mesh. You can configure meshes in different ways, and we were using just HTTP bin in these tests. We're just hitting a very simple service and having it respond back. What we're seeing here is that between this particular configuration of Istio and Linkerd, the differences seem to be marginal, not nominal. But the takeaway, that wasn't so much what we were trying to test. What we were trying to test is, what's the relative slowdown? When I just ran that test a minute ago, I did it at a concurrency of 1. So it was basically a single-threaded load generation. And I'm not going to educate folks with something that you probably don't know, but if you're running more threads than you have cores, those cores need to time slice between those threads. They need to context switch. And there's a slight bit of overhead to that context switching. And so what we were really trying to test here was, for a given service mesh, as you spin up more threads than you have cores, what's the cost of that context switching in this case? And this was it. And this is measured in times. So the cost of context switching for 100 threads at the QPS that we were giving it at the, with all of the data isn't shown here, but or all the environment configuration, but is pretty high. About 9 times as high as it is if you were just running. If your service was just receiving, your service is sitting there running on a VM or a host. It has a certain number of cores. If it's getting more connections, than it has cores to draw on, there's the context switching that happens, and so point of interest. Something that maybe service meshes could, they clearly have insight into, they clearly get affected by. Maybe they could do something about it. So turns out we didn't have a showdown, but we had a slowdown. This is a different picture of the slowdown, and highlights that under a different configuration for Istio, this Istio 1 configuration it's kind of the default profile for Istio. It's the one that has distributed tracing enabled by default. It has the sample rate of that tracing set to 100%. And that is, I think, true as of 1.1.3, but may have changed here recently, just having understood that there is cost to generating spans, generating trace IDs, passing along the spans, and collecting that. And so there's a cost to telemetry. And of the telemetry, that's arguably the most expensive, at least between metrics, logs, and traces in this case. This is probably the traces. And so to get that white box visibility, the distributed tracing view, which is fantastic, there's some cost to it. So the question was, hey, to clarify, of the threads that we're talking about here, are these threads the number of threads that are available to the data plane, the service proxy, the service mesh that's receiving traffic and processing that traffic, or are these threads that are being given to the load generator that I was just running? And it's to the load generator that I was just running. And so in this case, like 8 threads spun up on the load generator, and in that particular environment with that single VM, it had 8 cores.
So the load
No, sorry. The mesh had 8 cores, and the load generator, we started with 8 threads, like a 1-to-1, to kind of baseline. Okay, well, hey, with no time slicing, with no context switching for that CPU, sort of, what's the conceptual optimized, maximal output? And so then from there, we said, well, let's double that. And then we decided that was taking too long because we're running it for 5 minutes apiece. We skipped to 100. So understanding that I've been speaking at you for some time, there are other things I think to talk about here. It's probably good to mix it up with some others. And Spike is already starting that. Thank you. Thank you for clarifying, Spike. That was very helpful. This is a diagram of just, in this case, of some telemetry processing. So I said, looks like there's some expense and some cost to gathering that telemetry. And it makes sense. Like it's very insightful information. In Istio's world, it's Mixer as the component that deals with this. And Mixer has this adapter model where you may be using either open source or some vendor's software to capture metrics or capture spans and look at spans. And so different vendors and different projects have built adapters that go into there. In my mind, this is a bit more of the management plane, kind of what we were alluding to before, sort of the other software that you would be using to control things. To hopefully explain this quickly and well, there's lots and lots and lots of tests that I think we're going to be running and publishing reports on. This one, again, just diagrammed this morning. The test was to say, hey, is there a difference for the way that these service meshes perform by going out and pulling down a 10 megabyte binary image, or a 10 kilobyte, or a 10 byte? And what we found was, and again, and all the details need to be published subsequently, because it's like, well, what was the environment? What was the app? What was the environment is kind of the same one as a single node. It's we will publish the details, so do look for the slides. I think that the takeaway here was, in this particular environment, it really wasn't much difference at this larger byte size. The same was really seemed to be true for the 10 kilobyte byte size. And then the third test that we'd run was for a 10 byte. It's just a super small request out to HTTP bin. And since these are just an hour or a couple hours old, my guess is, if you figure this out and you've got a different perspective, I had said that I was going to try to have tough skin on Twitter, so so do your worst. My perspective is that of these super small requests that are being made, they come back lickety-split. So I hadn't gotten to use lickety-split in a while. They come back pretty darn fast. All save for maybe that initial setup where what you're getting here is encryption, both from these two deployments, where Istio and Linkerd are both providing the mutual TLS. And hey, maybe the setup of that takes a second longer than than what we're looking at here. These are in seconds, so it's these are less than a second response times back. So maybe it's that long tail that we're looking at, is maybe just that initial establishment of encryption, and then from there. And so I was talking about Meshery, this project. One of the things that it is attempting to do is provide something of a service mesh benchmark specification, so that you can really begin to export your test results and share those around in a consistent way, so that your test results could be comparable to others. And so, we're inviting the different service mesh projects to participate there. I do want to pause and expect everyone to take a picture of this, so that you can tweet out to these lovely contributors of their free time. I occasionally feel like the odd one out here. I am so pale. It's just but with that, enough from me. Do go read a service mesh book. I encourage you to. Let's maybe just take a 5-minute recess, grab some drinks, use the restroom, come back with your questions. We're going to bring up 5 panelists that represent some of the service mesh projects that we've talked about, and some that you maybe haven't seen yet. So let's do 5. Welcome back. Let's get meshy. All All right.
He had to actually spend the entire break thinking of that one.
That's all I came up with. Very good. We will, let's get going. Let's get some other voices up here on stage. What a crew we have today. I'm honored to introduce the panelists that we have here. There's a decent representation of the various service meshes that are out there. There are more meshes than there are seats up here. Hopefully we do as much justice to service meshes in general as we can. If I could ask our esteemed panelists to maybe just self-introduce, and maybe, Spike, maybe if you would start.
Sure. So I'm Spike Curtis. I am a software engineer at Tigera. We focus on networking and security, network security and compliance for Kubernetes. We don't have our own service mesh or anything, but we are doing a lot of work with service meshes, and I am one of the co-leads of the Istio security working group, and I also am a maintainer on the Spiffy project.
Hello, I'm Chaim Hellman. I'm the CTO of Octarine. We're providing a security solution for applications running in Kubernetes that is based mainly on Envoy. So we have solutions that work both with service meshes based on Envoy or with our own control plane.
Hi, I'm William Morgan. I'm one of the maintainers of Linkerd, which is an open source cloud native computing foundation service mesh, recently featured up there. I'm also the CEO of a company called Buoyant, which provides support and services for companies that want to adopt Linkerd.
Hi, my name is Manish Chuktu. I'm the CTO for Avi Networks. We at Avi primarily make software load balancers and have been doing pretty similar things like service mesh. We didn't call it service mesh since the last 4 or 5 years with our customers.
Hey, I'm Zach Butcher. I was an engineer at Tetrate, which is a company that was started by some of us core Istio developers. Before that, I was one of the early developers to start on the Istio project.
Oh, very good, very good. Good to have you guys. Today, we've been introducing a lot of you to service meshes, which means as your interest unfolds, you'll go about adopting a service mesh, hopefully. And that's kind of the theme to our panel today, about adoption. And maybe that's even the first question. And maybe a bit of chaos up here is good. I'm gonna throw this one right in the middle. But in your mind, we talked about some of the value that a service mesh provides, but what has been your experience as to really why it is that people are choosing to adopt a service mesh? When it is that maybe they're turning their back and saying, no, I actually don't need this thing. What have you seen? I'm going to toss it right in the middle, just to.
What is the?
I'm
in the middle.
That's William.
All right. See, I chose this seat because I figured I would not be asked the first question. Traditionally, we start on the sides, but okay, I'll go for it. So I think we have a little bit of a unique perspective in that Linkerd was the very first service mesh and coined the term back before the term existed. So we've been kind of been able to view the many stages of evolution of the service mesh, ranging back from circa 2016, where no one wanted to hear it's like a new term, and like no one wants to think about a new term, all the way to I guess almost mid 2019, where the hype cycle is now like at hopefully at its peak, but you never know.
Hope so.
Yeah. And now everyone knows that they need a service mesh, but they don't necessarily know what it is or why, but they know they need one. So that perspective, I guess the reasons why people have adopted it, I think there's a couple reasons, and I think you touched on most of them in your intro slides. There are some very engineer-facing reasons, right? There's reasons like I just need telemetry, and like I just don't have a good way of doing it, or I need a way of putting kind of these security policies in place. There are engineering challenges that it solves, but I think fundamentally the thing that it provides and the thing that makes it have such a huge impact on organizations that adopt it is the decoupling, right? It's the decoupling between the platform owner, team, which comes in various forms, and the developers. And it's nice that the developers don't have to write their own retry logic. And by the way, like that's really hard to do. And okay, we can extract that all, and they should be focusing on business logic. That's great. But it allows the platform team then to have ownership over these kind of fundamentally platform concerns around security and reliability that otherwise are in the hands of the developers. And I think that organizational shift is a thing that is really valuable. So to me, it's less of a technical thing. I mean, the technical details are cool. I used to be an engineer, so I like that stuff. But the organizational aspect is kind of the core value.
And I will say, I think you're so spot on, right? It is exactly the centralization of control and consistency that this mesh architecture provides that is the key winning thing. But we do see that most of the reason that people start to adopt the mesh is the engineering-centric reasons, because you don't start to realize that organizational change until you actually start the adoption process, at least as far as I've seen, right?
Very good.
I guess I'll address the second part of your question, why people are kind of hesitant. And I think essentially it's introducing another level of complexity. So you have another thing running in your data plane. The problem is never the control plane. It's always having the proxy. And what does that mean in terms of latency? What does that mean in terms of stability? How do I monitor another component that I didn't write, was really not in my control, and I have no control over the roadmap of that specific feature or that specific component. The second part, I think, is as your platform becomes more powerful and you have more features, and Istio definitely has more features compared to Kubernetes, you start seeing a lot more friction with the way you're used to doing things outside. So if you're doing authentication in a certain way, you manage your certificates in a certain way, you have a way to do routing that works, and it worked outside of your cluster, and it worked inside of your cluster, and it worked everywhere. Now, sometimes you need to find a way to bridge the way things used to work and the way things work with Istio or with incur, and it's not always easy to reconcile.
I have a counter question, a reverse ask.
Oh yeah.
Which is any of our? So I agree with all those reasons. Are any of them specific to the service mesh, as opposed to general reasons to adopting any new piece of technology? I'll throw that right in the middle. No, I'll throw that on the sides.
I mean, I think that there is this kind of resistance to change, and even us people that work in tech and think that we're really innovators and embracers of change and can still get into those sort of ruts, but service meshes, we talked about these organizational changes, and we talked about how this is now a platform thing. Making changes on large scale is something that makes the service mesh different than just any old kind of technological change, and kind of taking decisions that were made in one place in an organization and moving them into a different place in the organization is often very difficult, and also there's an amount of kind of complexity that goes into a service mesh that it was easy to kind of think of your life and your service and your development as being simple in a way that a service mesh kind of adds cognitive kind of complexity. Like if it goes well, right, and you can convince the developers that you had these problems that you used to have to care about, and now you don't have to care about those, and you can focus on something else. If that goes well, and your developers are happy to stop caring about those things, then their life sort of ends up simpler. But if they can't let go and they want to keep caring about those things, now their life is much more complicated, and so it is an overhead that you have to kind of understand when you're biting off service mesh, and it's the kind of thing that pays when you make these big platform investments. That's the kind of thing that pays dividends across a large group of services, a large group of developers, a large organization. When you have small, nimble teams, you're not paying like the amount of value that you're going to get out of deploying something like a service mesh may not be the same.
Yeah, I agree with all of you guys. I guess there are three types of organizations out there, right? Guys who have actually containerized their the services, the monoliths into big containers. Guys who have actually truly done microservices architecture, right? There's a lot of guys who fit in the first one. They have containerized the services, which is great, because now it's developer agility. They can deploy faster and whatnot, right? So they've crossed that impediment, right? But they haven't really truly gone to the place where they have microservicized all the services, right? Service mesh is good for the second case. There are a lot of microservice-based applications running, and they're communicating with each other, and you want something like service mesh, and we all know what capabilities and benefit it gives us, right? So there's no debating that. It's a must for those kind of services. But I see a lot of customers, personally, and talking to my friends, who still are in the first one, right? One big thing that I've figured out is, and when I talk to those guys, is 80% of their traffic is still north-south compared to east-west. So when you have that kind of scenario, does service mesh hold good for you, right? There's again a thin line around whether service mesh is just true for east-west, or is good for north-south also, where the ingress gateway is coming into picture. But those are the kind of things which people look at, right? That, you know what, my traffic is mostly north-south. Do I still need service mesh, right? If my traffic is east-west and I really need policy control, I need observability and telemetry and all that stuff, service mesh might be a good choice.
Just to touch on that some, and this is something that I may get flamed on for Twitter, so we'll see. That is true. I would make the argument that as you move to a microservice-based architecture, and as you have more teams that are building services and consuming services, the distinction between north-south and east-west traffic becomes less and less important, because it all looks pretty similar, because you're all consuming services or not. And as you move to better systems of identity, better systems of traffic control and policy, it becomes less important that it happens to be consumed from inside of a network that you manage versus from a network that somebody else manages. So I think looking forward, I will have that distinction less and less over time. But for sure today, there is a strong distinction there in how people conceive of and treat north-south traffic versus east-west, internal traffic versus external traffic.
Yeah, and that was the point. The point I was trying to make was the way you need to deal with north-south traffic as of today is a little different than the way you deal with east-west traffic, right? In terms of just the scale and security requirements that you have for north-south, right? And even the performance requirement that you have for north-south is a little different, like TCP or TLS for that matter, right? And those kind of stuff, right, is very north-south related, or DDoS protection in your proxies, right? Which is still, I believe, a gap in the service mesh architecture if it's dealing with the north-south thing, right? Just to make that point.
Very good. Oh, well, we've yet to really like get something happening here. I'm going to see if let's walk that way. There are so many nuggets to what each of you have said. I guess in context of our theme of adopting, I've heard a few of you characterize adoption by either different types of teams, different sizes of those organizations, volumes of traffic, or sort of belief in the return on investment versus the complexity of sort of yet another thing in their environment to grok and deal with. And I guess I'll postulate and put out there in the proverbial middle, or maybe since it's going to the middle, maybe I'll hit William with this, is to, again, sort of going back to my simple mind and saying, well, hey, I think I understand container orchestrators well, and they've just been here longer, so I've had longer to digest them. I understand that they're somewhat different. Some of them have more constructs, some of them have less, some of them are easier to deploy, some of them are more difficult to deploy, some require more maintenance, and I would postulate that there's some similarities to be drawn to some of the offerings that we have today, some of the projects that are available today. So in context of that, my question is, do you consider, or what sort of key indicators do you consider are points of inflection, or kind of key indicators as to that's when you know, or here's when you're really going to benefit, or that's when you know you should do this. Maybe it's, hey, things are too complex and so you won't get the return on investment, or hey, you've got too much of your traffic elsewhere, or whatever those things are.
Yeah, I like the framing in terms of ROI, because it makes clear that there is both there's a return, but there's also an investment. And whenever you're making an ROI decision, right, you have to look at both of those. And I think the return, certainly the experience that we had with Linkerd. So I mentioned that Linkerd has been around for a couple of years. We have gone through a very substantial transformation from the 1.x branch to the 2.x branch, in part on based on a lot of lessons learned during 1.x, which was very widely adopted and continues to power massive portions of the internet today. But the value, what we learned with 1.x is that the value props were there, right? People were getting value out of the security and observability and reliability, but the cost that they were paying to get there was high. That was cost in terms of machine resources, sure, but that's way less important than the cost in terms of complexity. Like, human beings were having to spend their time understanding these complex constructs, and that was the real cost. So with 2.x, and we just released 2.3 last week, maybe the week before, there's been a concerted focus for us on reducing the complexity, reducing the operational footprint as well, but reducing the complexity so that you get the value propositions, right? You get the R, but the I is significantly lower. And so when to pick on Istio a bit, when I hear people mention, the complexity of the service mesh is complex, in my mind, I'm always asking, are you talking about the service mesh or are you talking about Istio? Because those are two very, very different things, and I think Istio is particularly complex, and I think it does maybe you'll flame me on Twitter, I think it does a huge disservice to users by its complexity. And it's not complexity at like install time or like, oh, I gotta, whatever. It is long-term complexity. And I think that's a real problem, and I don't think that's endemic to the service mesh itself. I think a lot of that is a function of Istio, and Istio is what is in people's heads, and therefore you're kind of ascribing these qualities to the service mesh as a whole. And I understand why that happened, right? We did the same thing with Linkerd 1, right? We went through that journey as engineers, and we were like, oh, we got all these features, and we're going to add all these things, and like, let's have it do this and this and this, and like, why not? Like, more features are better. And no one was kind of having any real empathy towards the end user, and it took us a long time to learn that lesson. And so that has all been kind of worked back into 2.x. But ultimately, I think, for me, to summarize my answer to your question, it is the level of the return is there. I think we're all kind of agreed that there's a lot of value here. The question is, like, what is the investment? What's the I and the ROI that we have to pay in order to get there?
I think William is spot on in basically everything that he said. Istio is what happens when you go spend a bunch of engineering effort for a year and a half, and don't really interact very closely with users. Is that you have a lot of really cool features that can do a lot of powerful things. It's a Swiss Army knife with a lot of things in it, and it's really, really easy to cut yourself all over trying to handle it, right? And some of it, I would argue, is inherent to the problems that are being solved, and a lot of it is incidental complexity introduced by Istio, the system itself. To William's point, that inherent complexity in the mesh we can't ever do anything about that, right? So part of the networking domain is challenging. There are certain complexities that we have to deal with, and there's no getting around it. But what we need to do as a set of people here on the panel that are producing service meshes for others to consume is reduce the investment required, exactly as William said. And Buoyant and Linkerd as a project have done a phenomenal job of doing that. And that's something I want Istio to try and emulate over time. And it's hard, because it takes a lot of learning and a lot of working directly with customers to figure out exactly how you do that. And y'all have done an excellent job of that.
Thanks, Zach. I appreciate that. And I think, just to kind of pile on more, like, I do think, and you can quote me on this, I think Istio is a bad project, and it's bad because it does a disservice to its end users, and it's not bad because Zach is a bad engineer. I think Zach is probably a better engineer than I will ever be able to become, but I think there's a fundamental disconnect between what the human being who has to operate this thing over the next, the course of the next couple of years, who's building their career on top of this thing, whose job is on the line because they have to make the service mesh work. I think there's a fundamental disconnect there, and if that loop is not closed, we can think about why there's a disconnect. There's like, I think part of it is like, it's a consequence of like massive amounts of marketing, like just kind of puts a wet blanket on any kind of realistic conversation you can have, and then there's parallels to OpenStack, and we can get into all that stuff. But I think if you cannot have that fundamental loop between the human being who has to operate this thing and the project, then like you're doing a disservice to your users, and it's not the right thing to do. Sorry.
Yep. Thanks. I know I'm caught between Linkerd and Istio here, but
wait till we talk about performance.
Yeah, exactly. Yeah, but you're right. Both of them are right. When we talk to our customers and we ask them, hey guys, you're using Kubernetes, you're a microservice-based architecture, so you want to do service mesh, right? They say, yeah, we are trying it, but damn, it's complex. And he's right. Most of the times we're talking about Istio, right? Because that's what they end up trying. That's the most popular one, right? So far, right? And say it's complex, and we didn't sign up for this. We signed up to service mesh so that it solves our problems, not to add complexity to our problems, right? I now need to manage, like you said, 6 different projects, right? To do my tracing, to do my logging, to do my monitoring, to do whatnot, right? I've got
48 CRDs.
48 CRDs, right? And all that stuff, right? You're so right. Somebody just mentioned that, right? There's so many CRDs I need to worry about now. So both of you're spot on, and that's I guess all of us need to really think about how to make this whole thing simple, right? Service mesh is there to solve the challenges that we have been talking about, right? And it does it wonderfully. It's just that it has to do it very simply. That's all it is.
That said, I think it's very important that don't wait for an inflection point. If you want the features of a service mesh, try a service mesh now. There's no reason to wait until you have an X number of services, a certain size of deployment. It's only going to get worse. So you want to start as small as possible, which is probably as early as possible, and grow with it. So choose your project, evaluate the options, and figure out what works for you, and then go with it.
Yeah, install it right now. You're sitting here in this room, you've got laptops. You can go to run.linkerd.io, and you can install it on your laptop. And I'm going to be checking laptops as we exit these doors, and no one will be allowed to leave unless they have a functioning service mesh.
For what do those that install get? Tell the audience what they get, William.
They get to leave.
They get to stop listening to us.
No, I'm actually going to disagree with Chaim and not sort of make a blanket statement that you need to start now and you need to start deploying this stuff. I think that like realistically, I definitely agree with William about thinking about ROI and what are the returns, what are the investment. I'm going to take a slightly orthogonal way to talk about it. So not disagreeing with William, but another way to think about this is kind of what are you trying to solve as an organization? What are the problems that you're dealing with, and what are the urgency of the different problems? And so one way to answer the question, do I need a service mesh? When should I deploy a service mesh? Is to honestly be reactionary, right? Like look at what you are needing to do in your organization. What are the things that are bad about the way you're running your application now and is going to get you to the next level? And if one of those things is one of the things that service meshes is going to help you solve, then now might really be a good time to get on it. But be honest with yourselves and know that like, you know, deploying a service mesh is going to take some investment, and there's opportunity cost to all investments, and so you will need to weigh that against what else is going on in your business. So you can be reactionary, or depending on what kind of business you're in and what sort of mandate your group has. Like maybe you're the platform team and your job is not to be reactionary. Your job is to be skating where the puck is. If that's your team, if that's what you are doing, then by all means, right, get on this. Like this is a thing that's rapidly dropping. The I in service meshes is rapidly dropping as time goes on, and so it probably really is time for you to start looking at this stuff. And so sort of take where you are, what your team is supposed to accomplish, and make your play.
Yeah, I think Spike is exactly correct. If for people that were in my talk either this morning or yesterday, I had a slide that walked through traits of successful mesh adopters, and literally the first and probably most important point is, at least in my experience, the vast majority of people that have successfully been able to adopt a mesh had one thing that hurt, and the mesh addressed that thing that hurt, and they used it to solve that one thing. And then later they expanded that to solve more problems because they had the infrastructure in place, because they had the understanding in place, they had made the investment, and now they could start to realize returns in other areas that they didn't intend originally, right? But you have to be use case focused. You have to have a group of people that hurt, that are experiencing some pain that they need to solve. Otherwise, you're not going to be motivated to go and make the investment that's required, because it is a substantial investment.
Very good. I love these kinds of panels because I have to ask 2 questions and we get 35 minutes out of it. Very good. And I suspect each of you are biting your tongues at that. Because it's about adopting, let me attempt this question to put things maybe slightly more concretely and choose one. I'll choose a metric. And this is in part because I've heard my teams say this to me as well, and so I'll take it to the extreme and say, ask this: do you consider that both a service mesh provides value and provides the R of the return on investment if you're running a service? One service.
So
No.
you want? Yeah, probably. Honestly, probably not. If you have one, it's not that hard to go, for example, add the instrumentation that you need to go pull in a library that appropriately addresses the pain that you have. There are downsides to those approaches as well, right? Their library upgrade problems are hard, all these things. Those are greatly mitigated by having one. So probably not.
Docker provide value? Does Kubernetes provide
Yeah, I was going to
value?
say, is anybody in this room running only one service? Or expect to only be running one service for the foreseeable future? So, I mean, I feel like it's an easy question to answer, but it's also kind of moot.
And the answer being?
Probably not.
The answer being no. I mean, with one service, no. But that's not what anybody who's here anyway cares about.
I guess it completely depends on the use cases, right? Even if there are minimal number of services, I would still say no. If there are, let's say, even 10 services, I might still say no depending on what you want and what your use case is, right? So it's completely dependent on what your need is, what your pain points are, right? I have customers who are using Service Mesh just for observability. They don't really care about any other features of Service Mesh. I have customers who are using Service Mesh just for security. That's because their SecOps is kind of behind them. They want it to be multi-tenant. They want policies to be enforced the way they should be enforced across tenants or namespaces, right? They're using it for just that and nothing else, right? So it's completely dependent on your use case. I have customers who come to me say, we have 10 services running. Should we do service mesh? I said, well, what are your pain points with running these 10 services? We don't have any, but looks like service mesh is something we need to do. You don't. So it completely depends on your use case and your pain points.
So the funny thing is that 10 services might be the best place, maybe the best number to deploy certain service meshes. It's relatively easy. You don't get to the corner cases. There's a good chance that it's going to run out of the box. I mean, book info, it works, no problem. The problems actually show up when you go beyond the 10 services to the hundreds. And then you can see, you see where the bottlenecks are, where the corner cases are, and then it becomes more complicated.
So just one final piece here. To go back to exactly what William said and to echo what you said, which is exactly correct. Look at the calculation, right? Even if you only have one service, how much time and effort are you going to invest in instrumentation, in whatever the pain point is? It needs to be use case driven. So how much effort are you going to invest in? So like number of services is an irrelevant metric for mesh adoption. The relevant metric is what is the thing that hurts, what is the investment to fix the thing that hurts, and is that less than the investment in fixing it now with a different tool? And does that tool make sense moving forward, right? That's the calculus that you really need to do. Number of services is irrelevant. It's about developer effort and energy.
Is there anything mesh specific about that, or is that like a...
No, I mean, that's a generally true statement about adopting anything, right?
While we toss another one into the hopper, please do, I know that many of you have got questions. If you do, please walk up and I will hand you the mic. And so don't all get up at once, please. Just a couple of you sit back down. But if you would very politely and calmly walk this way, we'll get your questions answered. In the meantime, there's been a little bit of a theme also happening as we're talking about adoption. And I think actually it's one of the things that William helped open us up with, and that was just a focus on I'm not sure if I might slew this, but sort of the organizational benefits, the empowerment of fairly prominently ops personnel, but also developers over this new set of tools and the speed by which they can move. And today we've got we have dev and we have ops, we have sec. We've got those who's familiar with NetOps. We've got dev sec net. And so the question is GitOps. Yeah, we've got GitOps. We got hug ops, I think, somewhere. Question being, do you foresee, to whom does the service mesh mostly benefit? Does that just become another function under their current job description? Does a new focus and role emerge? Discuss.
That's a great question. Yeah, who does it benefit? So in my mind, if you follow the arc of things like Docker and Kubernetes and CI/CD systems and all that stuff, and the service mesh, I think, is a big part of this. The way we see this in practice with Linkerd, at least, is it's teams inside organizations that are building these platforms for the rest of the company, and those are kind of the first line adopters. And it's kind of funny that everyone is like building their own PaaS, and they don't want to use a PaaS, but they want to build their own, and they're building it on top of these components. And those are, at least from the Linkerd perspective, it is those people who are often not writing the code. Although in small companies, everyone kind of shares a lot of responsibilities, but in larger companies, they're not writing the business logic directly, but they are building the platform that allows the developers to do that in a way that, doesn't, where they don't have to worry about kind of the executional, complexities. But then there is a second audience, which is kind of indirect, which is the developers themselves, and because they are ultimately the customers of this platform. So to the extent that you can provide features that make the lives of developers easier, or then that's beneficial for everyone. It's beneficial for the platform owners who are going to be on the hook for providing a platform that their developers are enjoying, right? If they build this thing and everyone's bitching about it the entire time, then well, you did a bad job. So you want to build something that's really reliable and that solves people's problems, and that has things that make the lives of developers easy as well. So in my mind, that's kind of the secondary audience there. And then the third audience is, I don't know.
The security team.
The security team.
Yeah, so that's
putting
what
up
I was gonna mention.
roadblocks to progress.
Yeah,
Over to you, Spike.
I'll agree with William that the people that we at Tigera normally interface with as our direct customers, our platform teams, security teams. Those are the people that usually have the very direct goals that service meshes are going to help them achieve, and then you get that sort of benefit out to the developers, and hopefully the who benefits should extend out to the stakeholders or customers of your organization, right? You don't want to just sort of end with happy developers, right? You want to delight your customers or do some good for society or whatever is your organization's bigger goals are. Service mesh, like everything, should be supporting that, but the sort of place that we interface, I think mostly is platform sec.
It's predominantly either like a central traffic or platform team that drives it. And then what you'll see over time is security gets pulled in because now we have this thing and we can start to do cool security things, encryption in transit policy. It's a very natural fit, right? And then typically you'll have an observability team, a central observability team either start to be established or existing ones come out of the woodwork. You pull those together and you'll see either a platform team that's responsible for network and observability and some other things own it with a security team, or you'll see kind of a 3 split, right? At least in my experience.
All right.
And the benefit is those teams start to get pulled together.
Hello, folks. So I have not adopted Service Mesh, so I'm one of your kind of target consumers, I guess. I'm trying to wrap my brain, get a mind, kind of a concepts of how, what problems it would actually solve. And so, one of the things I was thinking about, I wanted to just ask you about, was more esoteric problems, like say rate limiting. I've run an API before, and when you institute rate limiting, you need to think about all of your clients now need to implement exponential backoff. So it ends up being something that you add that suddenly makes things harder for the client. And was just trying to understand with current service mesh products, is that something that the sidecar proxy would kind of just handle on the client side as well as the...
Yeah, that's one of the big reasons for this client-side proxy is because you have the ability to do things like some of these resiliency features where other resiliency features that you enable don't interact nicely with clients, right? So I institute default deadlines or I institute, whatever it is. It's not actually that hard to break clients with some of that behavior. 429s is a great way to do it, right? Resource quota limits is a great way to break clients. Being able to also put in place things like automatic retries with appropriate backoff is a powerful way to deal with those problems. And mesh, because of the architecture, because you have a proxy there that's handling the requests, you can, on the client side, start to affect those changes, right? And even for clients that are outside of your mesh, you can do things like emulate that behavior at ingress into your deployment, right? So you can have that ingress proxy be the client side sidecar for external clients.
I think that class of feature is a really good demonstration of the thing that the service mesh can do, because all the retries and timeouts and rate limiting stuff, that logic is hard to get right if you're doing it yourself, right? It's not, you start out by doing retries and you're like, oh, my web browser makes 3 calls and then it gives up and I'm going to do the same thing, and turns out that's a terrible idea. in a big distributed system. So that logic is hard to get right. It's totally independent of business. It's unrelated to business logic, right? Business logic is like, I'm foo and I want to talk to bar, so like talk, right? The retries is not in there. And it works best when it is done platform-wide. Yeah. So those are 3 characteristics of a feature that make it seem like it should be part of the platform and not part of the application. And so that's a really good demonstration, I think, of the sorts of things that the service mesh is directly valuable for. And there's interesting questions there when you're talking about things like retry policy. Okay, well, who owns, and I think Lee kind of touched on this early on, who owns that policy, right? Is that the ops team? Is it the service owner team? Is there a service owner team? Is it developers? Is it X? Is it Y? Like someone has to say, okay, this is how you communicate with the service, right? And that ownership has to be clear. And another kind of, I think, ancillary benefit of the service mesh is it gives you the opportunity to make that ownership clear, because unless it's codified somewhere, right? It's just like it's in some developer's code somewhere, and then they left, and now they work at a different company, and then 3 people have come and maintain this thing. Like it's this critical logic, which is like what is going to determine what happens to this service when load gets high, is like not written down anywhere. It's like this implicit part of the system, and that is a recipe for a bad time. So the service mesh gives you value simply by giving you a place where you can express this thing and say, okay, here it is. And here, someone has to own this, and you can pick who it is, right? But you have to write it down. It has to be there. It has to be like a first-class, member of the like ontology.
So one quick question: is there any work that's being done to standardize the service mesh so users can express their policies in a standardized way and use any mesh they want to?
That was my question too, actually. We've been seeing a lot of fragmentation at that level these days, for sure, right?
I think everyone's just like, just using Istio, so let's just treat that as a standard.
Well, that could be the answer.
No.
Why not? But yeah, that's a very valid question. I guess we all do agree to the fact there is a lot of fragmentation happening in that space. You got Istio as a control plane, you got Linkerd, and you got big clouds having their own control planes now, right? The good thing though is most of them are using some kind of the same data plane, right? In some sense, right? And the same protocol.
Not us.
No, definitely not.
Nope. God, I'm at the wrong place here. But
it was too slow.
Okay, we can get into that. But yes, that. I guess there is an effort going on. At least I did see Google announcing an open API initiative with Istio and do something.
That'll solve it. There we go.
That may not.
The benevolent
that may not solve
dictatorship.
it. But there is something. People are thinking about it. So there is a seed that has been sown, right? People are thinking about it. People are worried about it, and you're right. And if that doesn't happen, I'm going to get logged in. I can get logged into Linkerd. I don't want to get logged into Linkerd too, right? So that has to happen.
So Spike, did you have?
Linkerd loves you.
Yeah, I was going to say that, like, I definitely feel, the pain of the question that you're asking, right? Like we want these standards. We want to be able to do this in a way and have it like be a part that can be replaced. Manish just talked about there's fragmentation, and actually I wouldn't quite use that word, because it wasn't a thing that was like one thing and then like broke into pieces, right? Like we've got these different projects that are all growing up, and we're all making different choices about features and stuff like that, and so eventually, as a sort of industry, as a kind of product segment or whatever, you can start to figure out what are the commonalities, what are the ways that users want this to look, but that takes time, right? It takes some experimentation, and so we can't just like stand up and like have a committee and write the API and have everybody use the same API. Like we're just not there, and so
and that API would be awful, because we don't have enough experience in what. Like, service mesh is still very young, a very nebulous thing, right? Yeah. One thing I will say is I would caution against lowest common denominator APIs, right? Those are almost universally awful for users. And so a rush to standardize too early is likely to introduce that, right? The primitives that a system exposes are probably the most important part of the system, right? Because it's how you interact with it. those are hard to get right. We have conceptual differences between the things that a mesh exposes between different meshes. We're still trying as an industry to figure out how does this stuff fit together, right? And it's not until we go through that exercise, this is exactly what Spike was getting at. It takes time, right? Standardization takes time. We have to have many implementations first. We have to figure out what works, what doesn't work, before we can start to, as an industry, converge, right? And so I think it'll take many years to get there.
So what a fantastic question. And but A, we are at our time. B, there's a cliffhanger to be left here. There are efforts in the works to that very question by more than one set of folks. So TBD. How do you like that? We'll see you back at DockerCon. That's what. I do want to very much so thank our panelists today. Very appreciative of the answers and the sharing that you've given of your time and of your sarcasm. Thank you very much.
I feel like that one was more directed than the others.
Very good. Thank you very much. Yeah.